This one is the magnesium sulfate.
So now we're adding magnesium sulfate to our third test tube. Okay, here. There it is. So this is what our magnesium sulfate looks like. See, it's got kind of a yellowish tint to it already before we add anything. Okay.
Here comes the silver nitrate. Yeah, something like that.
Yeah. Oops. Okay.
A little lighter.
So this is after the addition of our silver nitrate to our magnesium sulfate. What are we seeing?
A lighter yellow.
Maybe.
Looks a little cloudier too. A little bit.
Just a little.
Just a little bit, yeah. Okay.
This is why this is good. What does that mean? Anybody, not Raven or Jay, what does that mean that it changed colors or that it got a little cloudy? Does that mean anything?
There's a chemical reaction.
That's a chemical reaction going on. That's how you observe a chemical change. Very good.
Okay. So now for our fourth test tube, we've got ammonium chloride. How is it looking to begin with?
Clear.
It looks kind of clear.
Okay, looking kind of clear.
Yeah, it looks clear.
Let's see.
Silver nitrate. Oh, I know I saw some. You see that cloudiness?
Yeah,
Oh,
for sure.
it's so slight. I need to use a different dropper.
Yeah.
Mm-hmm.
Now, you said that's ammonium chloride?
Yes.
Oh yeah.
Okay. Can y'all tell? That's not better.
You got a piece of white paper?
Yeah.
Put a paper towel behind it.
Is it kind of cloudy?
Nope.
You can't see that.
Yeah, that's too.
Maybe it's
Yeah.
got something dark.
Yeah. So it is cloudier now with the ammonium chloride and the silver nitrate, right?
Magnesium sulfate.
Magnesium sulfate. Okay.
Are you gonna do ammonium chloride with silver nitrate? Is that on there?
Yeah, isn't that what you said?
Oh, yeah.
Yeah, okay. Once again, ammonium chloride, okay? So we're seeing it's cloudier now, but not really much of a color change, just a little bit cloudier.
Yep. What's the concentration of your silver nitrate? Do you know?
It's very, very dilute. That's why the reactions are so
Yeah.
That right there should definitely
Let me
give
see
it
if
your
I can
precipitate.
strong.
Adding silver nitrate and ammonium chloride, you should have precipitated out some silver chloride. So maybe if you make it a little bit more concentrated, you'll be able to see it.
So yeah, that's what she's doing now. She's making it a little bit more concentrated. And that's one of the things that you see with the lab. If it's diluted, you're not going to get the same results that you would expect with certain chemicals. So you want to add more to this one? Okay. So now we're going to add more to this same ammonium chloride
Yeah, let's see what happens.
and see what happens.
I can see that
Oh,
from.
no. It's so dilute.
Yeah, it's still super dilute because it's not getting a whole
But it's
lot of
cloudier.
difference.
It's cloudier than it was though.
Yes.
Yeah. If it was more concentrated, you would definitely see a precipitate because silver chloride is not soluble in water.
Mhm. Okay.
Water.
And so now we're going to try and see what happens when we add water. So our fifth test tube has water in it. Okay, and I mean, it's water, so it's clear, not really any color to it. Okay. What are we seeing?
Maybe some cloudiness.
Are you expecting any change though, when you add water to silver nitrate?
It shouldn't change, right?
Shouldn't change, so it looks pretty much the same as before.
Mhm.
That makes sense, right?
Cloudiness is probably from the silver nitrate itself,
Mm-hmm.
unless your water is
That would
contaminated.
explain why it's not acting right. Because it's supposed to be really soluble, you can still see all these little.
But even here, you can still see the difference. So this is our water, and this was our ammonium chloride. So you can still see that one's cloudier than the other.
Absolutely. Need some black construction paper,
Yes,
like back in
yeah.
the day, like the kindergarten paper.
Anybody have any questions while we prep for round 2?
Yeah, any questions? And any feedback? Is everybody okay seeing everything? Was the video clear? The directions, all that stuff clear? Anybody have any questions about anything?
On the so on the chart, how we're basically like saying what we're observing in that first chart.
Right.
Do
Yes.
we use these, like I noticed in the YouTube video it says like ID code. So like for a precipitant plus a color, it's PC.
Yep.
Do we need to write that down or write everything we observe?
Just write the code in the box.
Okay.
Yeah. You can put a little key at the bottom to explain what all the abbreviations mean.
Okay.
Just write what you see.
Yeah.
Thank you.
Is this room recorded? I just wanted to make sure.
It is.
It is, okay.
Okay.
We can go ahead and do one. What's in it again?
NaCl, is that the first one? Are we doing, it's the same, right?
Yes.
Yeah, so the sodium.
So we're repeating
Calcium.
the test with all our reagents on the same 5 chemicals that we originally had, except this time instead of silver nitrate, our new reagent is going to be sodium hydroxide. Okay. So now we're in the second row of the table, or whichever row where it says sodium hydroxide.
So first, again, this is our
calcium
chloride, right? So you see, starts off pretty clear, slight cloudiness, but pretty much clear.
It's very difficult to get calcium chloride not to be a little cloudy.
So what difference are we thinking with this one? This is after the addition of the sodium hydroxide.
Anybody?
It looks the same or like clear.
Yeah.
So
Well, why is-
if you want to think about this a different way, there's a table. You can Google the table, or it's in your book, that tells you what salts are soluble, what salts are insoluble. That's a great table to memorize, not just for lab, but for class too. Yeah, but that doesn't look like it's doing. And you expect hydroxides to be soluble in water because of the hydrogen on the OH group. Right? It can hydrogen bond with water, and that's where your solubility comes from.
Right, and as Dr. Russell was saying, there is a really useful table that tells you the solubilities of lots of cations and anions. So when you look at the table on the row that we're on right now, you can see that both of these substances will combine to give you a soluble salt. And that's why it doesn't precipitate in water, because it's soluble. Okay, we're on our second chemical, which is sodium carbonate, and we're gonna add sodium hydroxide to it.
And so this one starts out pretty clear, right? So let's
Mhm.
I would sell my arm for a precipitate right now.
Okay, so this is after the addition of the sodium hydroxide. I'm gonna put it.
I'll buy anybody that's on here right now. I'll buy you dinner. I'll cash up you the money. If you write the reaction between sodium hydroxide and sodium carbonate in the chat and give the products on the other side, I'll buy you dinner. And Raven knows I'm good for it.
I was gonna say he's actually very good for it, so y'all might want to get
I'm good for it.
to doing
I'm good
it.
for it.
Can I
The first
do
person
it?
who does that,
No, you can.
I
No,
can
no,
do
no.
it. Okay,
Sorry.
okay.
you too advanced. But if you need dinner now, I got it.
I guess I'll let one of them have it this time.
So the first person that completes that, you get dinner.
So
Man, I wish I had incentive like this when I was in school. All right, so now we have magnesium sulfate. That's the,
it's got the yellowy color to it, a little cloudy. Okay.
and we add sodium hydroxide. Okay. You can go through it. Cleared up a little bit. Maybe not. No, it's actually cloudier. Yeah, it's got stuff in here. Y'all can't see it, but
I was gonna say, I know it's gonna be a little bit hard for y'all to see, but it's pretty cloudy in there. It's like little particles just in there. I don't know if y'all see.
So that would be cloudy with a precipitant?
yeah.
Okay.
Shout out to
And she's gonna add a little bit more to it. See,
Did that help at all? I can kind of see it clear.
yeah,
Some big ones for me.
yeah. So now there's kind of made the solution a little less dilute, a little bit more concentrated, and it's bigger, even bigger, little precipitate. So that's what that reaction is. I don't know if you guys can actually see it. But yeah, so that was the magnesium sulfate with the sodium hydroxide.
Next, we have ammonium chloride.
So ammonium chloride, once again, pretty clear to begin with. Now let's see what happens.
Using any gas or anything like that?
I thought I was about to see bubbles. That's why I was kind of like looking.
You smell?
if you notice what Jay is doing, that's called wafting. You never want to stick a test tube up to your nose and inhale.
I can't smell.
Ever in life. Yeah, you want to always
I
waft.
should be able to smell something because I feel like ammonia and foam in that reaction. But let's not tell them. Sure.
See, I want to see if it got
Why is that?
Because why do you want to waft the vapors to you?
It's safer.
Yeah, it's much safer, and it's less concentrated. Like those vapors, when they come up, sometimes it might seem like a little bit, but you got to think when you're dealing on an atomic level and a molecular level, even small particles affect your cells and your body and things like that. So
it's clear.
yeah, you want to always waft it to kind of make it less concentrated as you inhale it. Sorry.
Yeah, and of course, most of these chemicals are either toxic or just not safe.
Right.
to consume, so you don't want them anywhere near your face or your breathing parts.
That's
your
whether you know the chemical or not, just always assume it's toxic. That's what I do. Okay, so this is after the addition of the sodium hydroxide.
Clear, colorless, no apparent other change.
What's the initial chemical that was in there?
Clear.
Ammonium chloride.
Okay.
I was expecting the smell of ammonia, but I can't smell anything through this math.
Yeah. That's good. That's a good thing.
Yeah.
All right. Here's an easy one. It's water.
Yeah. Water again.
We add sodium hydroxide. And now we have a more dilute solution of sodium hydroxide.
Right.
So this is only a physical change. All that happened was dissolution. We don't see any evidence of chemical change here. Okay.
So any questions on part B?
Well, I got it.
So when we're not seeing like any kind of change, like no color change, no cloudiness or whatever, that's going to be like a no reaction.
Yeah, you can assume that there's no reaction taking place.
Yeah. Okay.
Give a shout out to Kaya. Is it Kaya or Kaya? Wade. Kaya. Yeah. Thank you for attempting the problem and winning a little extra cash out money today. And I will say this: your equation is balanced, which is great. The fact that you balanced it,
Nice.
yeah, that means a lot. So put your cash app in the chat and I got you.
Okay, we need another set. We can take the questions.
Does everybody understand what happened in A and B?
All right, so let's go for all our substances again, except this time row 3, our reagent is hydrochloric acid.
Do you guys have the zinc pellets to do that last part with the zinc metal? Isn't there a last part where you add acid to zinc metal?
I did not, you saw zinc?
I thought I did, but I could be tripping. So.
Okay, just go ahead. If you have it, that's great. If you don't, then we won't sweat it.
Okay. All right. So our first chemical is calcium chloride. And we're just gonna add a little HCl to it. Give it a stir. Okay, can y'all see that?
That was nothing, huh?
Yeah, why was it nothing? There's a common ion between those two chemicals.
What did you add? Calcium chloride and HCl?
Yeah.
That's a good question. But that, in order for that to be a reaction, one of those is gonna have to be basic, a little basic.
Exactly.
Calcium chloride is not basic, so that's why you don't.
Exactly. Adding a chloride to the chloride. And I'm gonna happen. All right, next is sodium carbonate.
Now you may see something here. You may see some bubbling.
Please let us see some.
So there's our sodium carbonate.
Is it fizzing?
It should fizz.
Most definitely, because that's
Okay.
and acid to baking soda. Not fizzing?
Mm-mm.
Do you have sodium carbonate powder in there that you made the solution from?
Mm-hmm.
Yeah, just drop some of that in a test tube, a little bit of it.
You said drop a little bit of sodium carbonate powder in here. Oh, we're baking soda. That's fine.
No fizzing.
Fizzing ain't supposed to fizz.
Can you add more HCl? See what happens.
Mm-hmm.
What's the concentration of the HCl? 0.1?
Like 0.5, around 0.5.
Yeah, it should have been a little
Oh,
bit.
there it is. There.
So yeah, it's kind of hard for you all to see, but there is definitely fizzing at the top. I
Yeah.
don't know if you guys can see, it's a little bit darker up there. It's like a little line.
Yeah. If you've ever added baking soda and vinegar together, then that's the same reaction because HCl is going to protonate, and you're going to have carbon dioxide release. So, but it's a similar reaction, not the same reaction, because vinegar is acetic acid and the HCl is different. But that's good. I think this experiment would have been better if the concentrations of those were higher.
Mhm.
That's a note that we can make when we write the next edition. We can increase those concentrations.
Okay, our next one is
Magnesium sulfate. Yeah, so this one starts off, once again, got the yellowish tint, tiny bit cloudy. Make it cleared up. So this is it now. She's making the solution a little bit more concentrated. So we can see if we can get a bigger reaction.
maybe add some of this powder to it. That'll help. I smell like it's impaired, I guess. Oh no. You're right, what you see.
Okay. So this is after. Are we seeing any differences? Oh yeah, there's precipitation.
Yep, a little bit.
Okay, so I don't know if you guys can really tell, but there's a little bit of precipitants in there.
It's kind of yellow too.
Yeah.
Since y'all were kind of breathing in it, does that mean there was a gas but no odor?
I didn't smell anything, did you? Did you see any fizzing?
Okay.
No, no fizzing, no gas.
Yeah, so no fizzing, so there was no gas, no odor, none of that. And again, that was the magnesium sulfate. Okay. Okay, so now we got the ammonium chloride. So we're adding the HCl to it. Can anybody kind of guess what we're expecting based off of what we've already talked about? Maybe.
Double displacement reaction.
One more time.
You said what's that in your hand?
This is the ammonium chloride. And we're gonna mix it with the HCl.
So would there be a reaction because y'all said something about having this two of the same like CLs, chlorides on both?
Right, so when they exchange anions, let's see what happens. You know, that's what it is.
Yeah. So yeah. Like Eli, am I saying that right?
Yes, that's right.
Okay, so yeah, like you said, because they share that ion, we're not expecting really anything. So this is after the addition of the HCl. Okay. And then last, we've got our water. Water is clear. Okay.
So no real visible change, but what physical change just happened? I mean, what happened to the sodium hydroxide, to the HCl?
I'm gonna take a guess. Is that a line at the top? Like, is that? So it's clear.
No,
Oh, it looks like there's something in there. Maybe.
That's the
this is water and HCl. So the only physical change that could have happened is the HCl dissolved into the water. So all we have now is more dilute HCl. That makes sense?
Yes.
All right.
Yes.
Okay, let me go get that unknown.
So are there any questions about any of the 3 sets of reactions that we did so far?
On like y'all mentioned, it was HCl and then sodium carbonate. I think that was the one y'all said there was a little bit of like a fizz on the top.
Yep.
Would that mean there was a gas?
Yes.
And then that one had no odor though.
Yeah. No odor.
Well,
Yeah, because some gases are odorless.
yeah.
Anytime,
Okay.
anytime you see bubbles, there's gas that will leak.
Okay. Thank you.
Mm-hmm.
Okay. So now we're getting our unknown.
And I really wish I had those zinc pellets. That's a cool.
Yeah. The zinc pellets.
I don't see no zinc pellets.
Yeah, I didn't see any in here.
There may be some in the
Iron chips though.
Yeah.
maybe some in the stock room, but I don't know if you have the key. What's that?
There's iron chips here.
Now the iron is not going to be as reactive. That's zinc.
So she's gonna go look and see if they've got the zinc pellets.
Yeah, that zinc is super reactive. Super reactive. You'll see a huge reaction taking place with that. Yeah, y'all doing a great job though. I didn't intend on talking this much, but I'm excited.
No. It's good. It's good.
Right. While we're waiting on that, does anybody have any other questions? Anybody have any questions about anything that was already turned in? I know I said I can't remember who it was that asked me about some help with one of those one of the dry assignments.
I needed some help like understanding the dry assignment because I was confused on like what the problems I was trying to solve.
Okay, which one was it? The gravimetric analysis?
Let me pull it up on my computer.
All right.
It was a lot of them because like I don't know.
Was significant figures, and then one was gravimetric analysis, waters of hydration, and then one of them was the Excel lab, graphing with Excel.
Oh, the XL one, and then the hydration lab assignment, the paper.
Once they're done, just hang tight and I'll pull it up on the screen. We can walk through it.
Because like
And can you? Speaking of that, I did need help
Oh,
on
awesome.
question 4, actually.
Okay, yeah, just hang tight after lab, and then we can go through it.
These are the things.
So it's fine.
You found some zinc. Is it zinc powder?
Yes,
Mm-hmm. Good.
that's good. Okay.
Because I think part C, is that part C where you add the HCl to zinc powder and then copper metal and something else?
There's no part C in this manual, Dr. Russell.
Really? Maybe I'm
Really?
thinking about the acids and bases lab.
Maybe.
Yeah, I'm getting old, man.
So now we're adding a little bit of zinc powder.
Yeah, and just add some HCl to it and see if we get some gas evolution. Is it fizzing?
Mm-hmm.
Yeah. Can you hold that up? You see
So
that?
there's some bubbles at the top.
That's really vigorous. Yeah, you can see that gas
You
evolution
can keep this.
with zinc metal and then HCl. So that's definitely going to be a,
Wow, yeah.
yeah, it should be pretty vigorous. Yeah. Yep. So that's definitely, what type of, what do you think? What do you guys think? Physical, chemical?
No, just hydrogen gas.
Chemical.
Definitely a chemical reaction.
Okay,
And
another
those
one.
bubbles, I'm gonna put it in the chat. So you have zinc, metal,
You wanna do
plus,
Zinc again.
with each one?
Yeah.
Okay, cool.
and zinc is a 2+ metal. So in the product, you're gonna get zinc chloride.
Okay.
And, hydrogen gas.
Also, you want us to try all the reagents with zinc or just certain ones?
No, that's fine. I
That's
just want you to see that gas evolution.
okay.
Yep. So if you look in the chat, that's the reaction that happened. So if you're giving off H2, hydrogen gas, then that's indicative of anytime you have gas evolution, that's indicative of a chemical reaction. But zinc just happens to be a highly reactive metal.
And that was an odorless gas also.
Yes. Yep. Is that it? Is that's all we're doing, right?
No, there's a part B.
Okay. Let me be quiet. Let y'all do y'all thing.
Okay, so for part B, we're gonna use the same 5 chemicals that we had before, except this time we're not gonna tell you what the reagent is. So you still write down your observations and you figure out what we added. Okay.
But the 3 additives remain the same, right? It's either gonna be sodium hydroxide,
Right.
HC, or silver nitrate.
Yeah.
Right?
Yeah. Let me hide it. I gotta hide it. So they don't see what's what. Yeah. Okay, so our first substance is calcium chloride. Wait, oh, there was, sorry, I need to clean one.
There we go.
Calcium chloride.
Beforehand, pretty clear. Okay.
I'll put some of this one. that precipitate in there? Okay,
Mhm.
so we have a little bit of precipitate. What color is that? Is that yellow or whitish? Okay. Oh, that looks white to me.
So we've got precipitate from this one, just a little bit. And that was the calcium chloride, okay? We'll go back through and show them again.
All right, next up.
So that would be like calcium chloride with the reagent A.
Yes.
Okay.
An A.
And so just write what you see once again. And so now this is our sodium carbonate.
Yes.
This is still reagent A. Okay. Not much happened here. Okay.
Next up, magnesium sulfate. A yellow tinted friend. And let's add some A. Ooh, a little more A.
Okay. So this is with our reagent A. And as y'all can see, yeah, we have precipitate. Okay, so there's a little bit of precipitate in there too. Okay. Remember, that's our magnesium sulfate. Ammonium chloride.
They'll figure it out.
Okay. And these are ammonium chloride with our reagent A.
So clear, like no change.
Yeah,
Or
but yeah.
is,
Yeah, that's right. Yeah. Okay.
Water.
Water.
You already know.
You should know what's gonna happen.
Nothing is gonna happen. Nada. Nunca.
So yeah, not much going on in there.
All you did was, like Jay was saying earlier, it's just additional dilution.
That's
Now you add more water to a solution, all you're doing is making it less.
Oh, yeah, we're good. All right, moving on.
So now we're going to,
B.
yeah, all again with reagent B. So starting back off with our calcium chloride. Yeah, look at me learning. Okay. Good. Okay. Yeah, a little bit of
Nothing.
okay. So are we seeing any change with this one?
no.
What are the contents?
Calcium chloride and reagent B.
Reagent B. Okay, all right.
I thought I was seeing a little bit. Okay,
All right, next up,
we got sodium carbonate with reagent B. Carbonate. Yeah, hold on. Okay, so this is,
oh, that's the one we had to superpose.
yeah,
Okay.
So is it no reaction?
Let me see that.
Where's
There's a little fizzing on top. I don't know if y'all can see it.
mhm.
Can y'all see the fizzing that's happening at the top, or is it too small?
Yeah, so there's a little bit of fizzing going on. Okay,
On to the next. What are we on?
magnesium sulfate.
Yeah.
Okay, so magnesium sulfate with reagent B. Okay. Yeah.
Okay.
it
Next one
looks
up.
to
It still has got a little bit of that yellow tint from the magnesium sulfate, but apart from that, nothing else.
okay.
But it's a little clearer.
A little, yeah, well, we added some clear liquid, I guess. All right.
Is our ammonium chloride.
Whew. Oh, and y'all, a lot of these have like no visible change, so you have to use basically the process of elimination to figure out which reagent it was. Just a heads up. Nothing. That's your bubble. Oh, in there?
Yeah, here that just stuff.
Oh, those look like, yeah, that looks like crap from the bottom.
Okay, cool. So yeah, not too much happening in there. Okay, so now we're on our water. And we should pretty much know what to expect with the water.
Nothing happened. Wow. Okay.
So yeah, water with reagent B, whole lot of nothing going on in there. Well, I won't say nothing because it is diluting.
Any questions before we do the last round? No.
Everybody cool?
Okay.
Cool. Great.
All right, so we're doing all 5 chemicals again, and this time adding reagent C. So first up, calcium chloride. I'm not offended by the silence, by the way. So I do the same thing.
Okay.
All right. Reagent C.
Action.
Should get some action.
Oh, definitely some
It's
action.
getting a little cloudy.
What's that crap in the bottom already?
This crap that was in reagent C already.
Okay, cool.
But I do see the liquid's a little more cloudy.
Yeah.
All right, we have a very pale white precipitate forming. And that was calcium chloride and reagent C. Next up, sodium carbonate. Let's add some reagent C. A little bit, maybe.
So this was
No,
sodium.
sodium.
This is our sodium carbonate with reagent C. How are we feeling about this one?
Is it a little cloudy?
A little bit. Okay.
Okay, which one are we on?
Magnesium sulfate.
Magnesium sulfate. PP code.
Magnesium sulfate with reagent C.
Yeah.
Mhm. Yeah, this is happening. Something's happening. Okay, so you guys should definitely see a difference. What do we see?
Is it yellowish?
Well, yeah, it started off a little yellowish. That's
We have a
just,
little precipitate forming.
yeah. So that's where that cloudiness is. Mm-hmm.
Yeah, and it looks a little more colored than the last one. The last one was kind of pale white. This one, I mean, obviously you can see the yellow tint in it. Ammonium chloride, yes.
Yes.
Okay.
Okay. Ammonium chloride. More in this. You're good.
Ooh, there's a little bit.
Yeah.
All right, we have another pale white precipitate forming. If y'all can see that.
Not a whole lot, but there's definitely something going on in there. Okay. Yeah, last one, water.
I don't even feel like doing
Oop, there we go. Clear.
Ooh.
Okay, and it's water, so we're not seeing anything. We don't expect to see anything. Okay.
All right, I vote that we try the zinc powder with all three reagents.
Yeah, okay.
Just to see what will happen.
Yeah, sure.
I got time to waste. But I put the zinc with.
So yeah, that was the last of the part B table. Any questions?
Now's the time. If you have a column
So
that's
like those the test solutions and stuff, those were the ones we used previously in the other
Yes, in part A, you just don't know which is which right now. It's the same three, they're just mixed up.
Okay, so the reason I'm asking is because some of the ones, even though I don't know necessarily what they are yet, for instance, like the calcium chloride, for the first part A, I had like no reaction for like almost all three. Colorless, there was not much cloudiness or anything. And for part B, on two of them, I have one of them with a precipitant and one of them with being cloudy.
Which ones?
How would I decipher which one? Just kind of, is that just kind of having to know the different solutions?
I'm asking which reagents gave you the cloudiness?
A, B, or C?
A and C is what I had for.
C for sure.
Yes.
And you said this was for the calcium, right?
Yeah.
Okay.
Yeah, that sounds right.
So
It's quite possible that we saw the change the second time and not the first
Okay.
time.
Okay.
That makes sense. Okay.
Thank you.
Yeah, no problem. Actually, let's ask Dr. Russell. Dr. Russell, should we do an unknown with more of the reagents A through C, or just call it right here?
This is fine. This is enough data. I overheard you say you were going to add the 3 reagents to zinc powder, though.
Yeah, that's what. Well, we were gonna do it just for fun, but
Yeah, no, do it. That can be bonus. So y'all can do.
sorry.
Add a little bit to each. So get 3 test tubes. Add a little zinc powder to each one, and then for those of you who are watching, you can write this down on a separate sheet and turn it in together, and this will be a bonus assignment.
So,
Okay.
look who's got extra credit. Okay, so zinc and reagent A. Ooh, gotta figure it out.
Okay.
Yeah. This is the one that should give us a little gas. Yeah. Oh, it's stuck at the bottom?
Mhm.
Try the end of this for a bit. No, I'm not seeing anything.
So this is zinc and our reagent A. Not really anything going on.
Oh, that still looks solid at the bottom though.
Yeah.
It doesn't look. It does not look the same color as before. Does it? Does
It
it?
looks really gray to me. I thought it was like clear at first. Right. Okay.
Can't tell this because there's not sun, but it is lightening.
Like there's still zinc at the bottom,
But it's still lightening.
but there's something clouding it up in there.
And that was, you said reagent A,
Hey, yeah,
which,
it might just be the dust one. Okay.
yeah, let it sit for a second while you're doing the other ones and then see what happens.
You already have one. Look at you. It's fat. Oh, my knees. Okay, so these are zinc with reagent B.
I'm gonna assume that that's. Yeah, we should go. Reagent B. Yes. Oh, I see. That I can see. I think I have to add a lot more for it to keep going. Ooh,
Trying for sure though.
ah, my hand's wet, sorry.
Okay. Yeah, that's it. All right, so you guys should be able to see this. Oh,
white precipitate and a little bit of fizzing.
Yeah. So I don't know if y'all can see the little ring of bubbles at the top, but it is for sure fizzing. So that means that a gas is being released.
Is that reagent?
And we got, yes. And we got some white precipitate in there. It's fizzing at the bottom. It's actually doing a lot of fizzing. I don't know if you got.
Sodium hydroxide is B, right?
One more time.
Sodium hydroxide is that B? Reagent B?
It's a secret.
Oh,
Yeah.
it's a secret. Okay, never mind.
We'll send it to you in the chat.
All right.
Yeah, so that's got a lot going on in there.
Mm.
All right, last one.
Okay. So last one is going to be our zinc with our reagent C.
No, we don't need that. For sure. Almost there. I guess it's not concentrated.
Just mixing it.
Will it settle?
Maybe which way I shouldn't see. It's starting to, I think. All right. So this is our zinc with reagent C.
It looks very deep gray and cloudy, but we're gonna let it sit for a minute too to see if anything changes. And then let's check back on the first one. Oh, a lot of that dissolved away now.
Yeah. And there's still a little bit at the bottom. I'm not sure if y'all can see.
We just did.
Yeah, but
The rest of the solution is pretty clear.
see you shake it up.
And can you confirm the fizzing? Because I wasn't sure what I saw either.
In here.
At first, before we let it sit. We added this.
So that one didn't really have any change? Or did it have a little cloudiness to it?
There was a little cloudiness at first, but most of it settled down to the bottom as we let it sit.
Okay.
Yeah, for sure.
That's you.
Okay. Just kidding. Okay, yeah.
Okay, that was the last one. Any final questions?
This one's still going too.
Oh, it's still bubbling.
Yeah.
Look at that.
And so this one, I don't know if y'all can tell, but it's still bubbling. Like there's a lot of bubbles in there.
You see it? Turn right there. Keep it right there. Yep. That's a really vigorous reaction going on.
Mm-hmm.
And that was originally.
Yeah. Mm-hmm.
Yeah. Wow. That's pretty cool.
Look at that. Scientists.
And nothing, if we still leave this last one?
It's starting to settle.
Is there still cloudiness in there?
Okay, yeah. Well, actually, I don't know.
It looks cloudy from here, but it might just be.
I can't remember how. A, B, C. That's what C.
No, that's clear.
Okay.
It's just waiting to settle.
So yeah, with last one, reagent C, that's pretty clear. It's just waiting to settle right now. That's why it's got that still a little bit of cloudiness to it. And as y'all see, that's kind of all sitting there at the bottom, at zinc.
All right, any questions about the table or any reaction, anything you need to double check or confirm?
Make sure you wrote down the zinc reactions. What happened?
Okay, cool.
I got one question. So I just want to make sure I do the thing right. So in between each like graph or chart, I mean, it says like sample number of unknown for part A. What is it asking that we need to put in that?
Dr. Russell, I'm not so sure about that either.
Okay.
Hold up. Let me unmute. Oh, I thought I was muted. Say that. Can you ask that question again?
So in between each chart, or like there's part A and then there's a chart, and then for the formulas, and then there's like sample number of unknown for part A
Mhm.
with a line. What exactly is it like asking?
So
Like I guess to put in there.
you actually did you guys did every sample, right? With unknown A, unknown B, and unknown C. Is that right?
Yes.
So it's not. It's like, okay. So that is there if you had taken like one of your samples and done it with an unknown, but y'all actually did all of them with A and then. Am I right, Raven? Okay.
Oh wait. Actually, for the first part, the sample number of unknown we only did with the HCl.
Okay. So you had. Let me get this. If I can get this.
You did.
So you had three reagents, right?
With the reagents. I thought the zinc was gonna be like our unknown. That's true. Because we did the zinc with each of those three. Okay, yeah.
So we didn't do.
So should we do them again, saying what the reagents are?
Yeah. We didn't do an unknown. We just did the three reagent. We did A, B, and C with each set of reagents, though. Is that right?
Yeah.
Do you want them to put the zinc there?
Yeah, you can use the zinc as the unknown. That's
We did
fine.
them in order, so we can just tell which we did.
Yeah. So yeah, you can just go ahead and divulge those details about that.
So the first reagent that we used for the zinc was the sodium hydroxide.
So we're back on the table.
Yeah.
All right, so we're back on part A, the unknown column. Where was it?
This is the first one we did. This one had the sodium hydroxide and zinc.
So you can just write that in, even though that
That's
wasn't
our
an
unknown.
experiment. Just write it in.
Yeah.
Okay.
This one is with HCl.
Yeah, so this is the zinc with the HCl.
So that will be unknown 2, right?
Yep.
Three. In the third row for the unknown.
Okay, in row 3. Okay.
This still going. And then this is our zinc with the silver nitrate.
And it's the first row.
And that's the first row. Okay.
Got it.
Everybody got that?
Okay.
Can you repeat it? Mm-hmm. So the first one we did was the zinc with the sodium hydroxide. Didn't really do much.
And that would be considered unknown 1, yes?
Yes, unknown.
In the second row for the unknown, the second row.
Okay.
And then this is our zinc with the HCl. So that's the last row. Okay. And then lastly is the zinc with our silver nitrate, and that's the first row. Okay. Any other questions?
Yep. Tell me the second one again. Zinc and what? I mean,
HCl.
the second row.
The second row is sodium hydroxide. That's this first one.
Zinc and sodium hydroxide. Yeah, that's
Yeah.
it. All right, I'm putting it in the chat.
Okay. Any other questions?
Okay, I'm gonna start cleaning.
Got it. Cool. This was good. Y'all did a great job.
Thank you.
Thank you.
So we can, I can answer questions now for those who had questions about the other labs. You guys can like mute and turn your camera off so you can clean up, and then I'll just I can answer some questions now.
I have something to say about your hydration dry lab.
Yeah,
and,
sure.
and XL. Like I looked up a tutorial for like the XL lab,
Mm-hmm.
trying to figure out like how to put the two graph variables together and graph data together in one variable.
Okay.
I turned mine in already because it was going to be past due. And I gave a little notification saying I tried my best and stuff, but I was just wondering if you would mind giving us a demonstration on how to work Excel because I kind of find it confusing.
Yeah, no problem. Give me 1 second.
And that's for graphing Excel 1 and 2.
All right. Let me open up Excel right quick and I'm gonna share my screen.
Mr. Russell, while you doing that, is it possible for us to resubmit all past labs?
You say all of them?
Well, just the ones that we need a clarification on.
Yeah, that should. You said you want to resubmit it?
Yes, sir.
I gotta figure out how to clear assignments out in Blackboard Ultra. So let me think on that. Because that Blackboard Ultra is a little weird. Can y'all see my screen?
Yeah, we could see it.
All right. Let me see if I got, because I think I had this saved somewhere. If not, I can just open a new file. No worries. All right, so you want to know like how to put the data together, yes? So give me what's on the x-axis in that lab. And this is recorded too, so you can go back and watch it if you need to. So what's on the x-axis? Is it volume or temperature?
I think it's volume.
And then what's the y-axis is temperature, right?
Yeah.
All right. Give me like the volume numbers. What are they?
The volume numbers are 8, 12, 16, 20, and 24.
16, 20, and 24. And then the temperature numbers.
200, 300, 400, 500, and 600.
Okay. So when you're doing Excel, to do a simple XY plot, you want to always, the numbers on the left, right here, those are going to be, that's your x-axis. And to the right of that is going to be your y-axis. So what you want to do is highlight both columns. Just select both columns like that, right? And then when you do that, I'm not sure what version of Excel you're using, but you want to go to insert. My computer is kind of slow. So insert, and then you want to do a line. I think it's an XY line, or I think it called for XY line or XY scatter. Let's see. Come on. Yeah, let me do this. Not include that.
Yeah, see, I was stuck right there because it would label both of them on the x-axis, and it would look like the graph would look like that instead of one being going.
Line, yeah. But it's actually shown. It's actually the. Why is it showing up as two different series? Hold up.
Okay, I think I can solve. Okay.
Yeah, it should
So
be.
I was about to say, if you go out of that,
Yeah, it should be an
okay,
scatter
go
chart.
to insert and then
Right here. It's a scatter chart. That's why it's showing up with both series labeled like that.
yeah.
It should be.
Yeah, I was able to just I didn't have those issues. I just followed the directions.
Yeah, but some versions of Excel are kind of outdated, or the newer version might have because that, let me not say that your version is outdated. The lab book needs to be updated. So the next edition we write, we're going to update it. But here's the XY scatter chart right here. But so if you're picking a line chart, then it's going to show the series separately. But if you do an XY scatter, then it'll plot them as the x-axis and the y-axis, and then you can go into the chart and add your axis titles and all that stuff, and then edit them like so. So this would be temperature.
Hey, let me ask you one more question.
Yeah, sure.
Did you go over the most recent assignment that is due today?
The dry lab for the gravimetric analysis?
Yes.
No, I haven't, but I can.
Please, I just need question 4.
Okay.
That's the question I'm like really confused on.
No problem.
Because in my class we haven't talked about mole yet.
Okay,
So
I got you. Yeah, let me finish this chart and then I'll pull it up. Right, so now you got your line here, and then you can right click, add trend line, it'll add that in. You can do a linear trend line, and then this you can also, when you go to add trend line, you can put that R squared value and the equation on the chart too. Right, and that's all it was asking for, to put the R squared value.
And like where you click, there's a checkbox or something.
Yeah. If you right click on your graph and where it says format trend line, this menu will open up. And if you got to click linear, linear is already chosen, and you'll go down and where it says display equation on chart, you just click that box, and display R squared value on chart, you click that box.
Awesome, thank you. Because like, am I allowed to resubmit this to get full credit, or is that just?
I may have already graded it, but for your own records, I would save it. I don't think I took any points off on that first lab. As
Okay.
you submitted a graph, I don't think I took off any points for that.
All right.
And now you'll know going forward how to do it.
Awesome, thank you.
Yep. Let me pull up the gravimetric analysis. I'm in Blackboard, I think. Let me go back. Duplicate that. So you say y'all haven't covered moles in GChem yet? Okay, yeah, it's not a problem. I'm happy to do it. Let me grab, I need to grab an iPad so I can share my screen. Give me 1 second.
all right.
And that was the gravimetric, waters of hydration dry lab, yeah?
Excuse me, I'm sorry. Can you repeat that?
The waters of hydration dry lab, is that was the lab you're asking about, right?
Yes, sir.
All right, give me a second. Let me pull it up on the screen, and then I'm gonna let's see. 233. All right, assignments. And right here, hydrated sauce dry lab. Open this up to get to the document. There we go. All right. So while that's pulling up, I'll just go through the other questions on there too. And if you've already turned it in, don't sweat it. I'm not gonna like go back and deduct points. I think I've already graded it anyway. So
I thought it wasn't due until tonight.
Yeah, it's not due, but some people have already turned it in.
Okay.
There's no problem. There's no
Were
problem.
you talking to me when you said you uploaded the document in here in the chat?
Yes. I think
Okay, I don't see this in the chat. Maybe You can forward this to me.
Yep, I can do
Thank
that.
you. I appreciate you.
Yeah, are you on your phone on Zoom?
Yes,
Yeah.
currently I am. Is that why?
Yeah, that's why you can't see it. It's okay. I can forward it to you. Let me open up my email and I'll forward it to you. Or you can just
Okay.
download it from Blackboard. 'Cause
Okay, it's on Blackboard.
yeah, it's there. It's there. It's in the very top experiment in Blackboard.
Okay. I just looked at your email and then I joined the call. But I got you, sir.
That's okay.
Hmm.
All right. So where are we? So which part? You said number 4?
Yes, sir. 4B.
Part B. Okay. So let me see if I could do something real quick. I want to take a picture of this and then write on it because I don't have a touch screen computer. So let me try something real quick. If I can get my iPad to focus. All right. Come on, work your magic. Give me 1 second. Okay. All right, cool. Let me share my reshare. Hold up. It's coming up. I think. There we go. All right. So it says in part B, calculate how many grams of water were removed from the hydrated salt. All right. So it says a 3.914 gram sample of gypsum, which is hydrated calcium sulfate, was heated by a geologist in a crucible until a constant mass was obtained. If the mass of the anhydrous calcium sulfate salt is 2.94. All right. So the key is right here. The key is that it's telling you that the new salt is anhydrous. That means it does not have any water left.
Okay.
All right. So if the anhydrous mass, no, let me write this down. So if the mass of the anhydrous salt is 2.194, how many grams of water was in the original? Were in the original salt. So you see the original mass is right here, right?
Mm-hmm.
The anhydrous mass is here. So in that first question, it would be 3.9. Sorry about that. My stylus is tripping. Maybe it's me. Grams minus 2.91. Right? It's coming. It's just there's a lag. So that's 1 gram.
Okay.
You lost 1 gram of water. So in the part B, it says calculate how many grams of water were well, it said percent by mass. So we got 1 gram of water and then divide that by the total amount, which is 3.914 grams of the salt times 100. That'll give you the water percentage. And then say how many grams of water were removed from the hydrated salt. Well, we just calculated that. So it's 1 gram.
Oh, okay. Okay. I see what that is. Okay.
And then I think in the next it says how many moles of water. I didn't capture all that, but I can still talk about it. So the moles of water, that's going to be grams divided by molar mass or molecular weight. That's how you get moles. So the grams of water, you have 1.0 grams, and then the molecular weight of water is 18. grams per mole. All right, so the grams are going to cancel, and then you end up with 1 divided by 18, but your answer is going to be in moles.
Okay, I see what that is.
You feel me? So once you know the grams, if you know the molecular weight, you can calculate the number of moles. If you don't know the molar mass or the molecular weight, you can calculate it. So like for water, that's H2O, right? Oxygen is 16, and then hydrogen is 1, so that's 2. So you add those two together, the molar mass of water is 18, right? All you do is add up the masses, the atomic masses of all your atoms, and that's how you get the molar mass. And then if you have a number,
Okay, thank you.
Number of grams, you just divide by the molar mass to give you the moles. Yeah, great question, by the way.
All right. So, and then what about? So it's pretty much the same. It's just pretty much the same questions.
Yeah.
Going down.
Yeah. Calculate how many moles.
All right. Thank you.
Remove. Calculate the number of moles of the anhydrous salt. So how would you do that?
You said how calculate the number of moles that are in the
anhydrous
anhydrous salt.
Is number D, letter D on that question. How would you calculate that?
All right. So when you so
can you still see my screen?
Yes, I can still see it.
All right. So the anhydrous salt, the mass we know is 2.914 grams, right? Because we drove off a gram.
Right.
And then we're just going to divide that by the molar mass of calcium sulfate. So what you're going to do is add up 1 calcium, 1 sulfur, and then 4 oxygens. I think the oxygen is 64.
Right.
So that's 64.
And I think you said oxygen was
16.
Yeah.
16.
Yeah, 16.
32 times 1. I don't know what calcium is. I think calcium is like 32 as well. So 16 times 4, 32 times 1, and then whatever the atomic mass of calcium is. Right, and then you just add all those numbers up, and that'll be your molar mass.
And then you just do the 2.914 over the molar mass, right?
Yep. That'll give you the number of moles.
All right, thank you.
Yeah, you're welcome.
All right, have one for that.
You too. Any other questions about anything else before we sign off?
I still have one more question. I just want to clarify what I kind of was asking earlier.
Okay.
Like in between those two charts on the lab we just did.
Yeah, let me pull up the actual document.
Okay.
And had it downloaded somewhere right here. Let me reshare my screen. All right.
Okay, so right
here.
There, yeah. So what exactly are you wanting us to put in for that?
Okay. So let me see. Part A, you did silver nitrate, sodium hydroxide. You can just put zinc right there.
Okay.
It's not a sample number because we didn't normally with this experiment, you have to like make up like 3 or 4 samples of unknown and then add reagents to each one of the unknowns. But because we didn't do that, you can just write in that we use zinc.
Okay.
Mhm. And it'll be the same thing for part B because we didn't do a part B. We just used that zinc and we used those 3 reagents here: silver nitrate, sodium hydroxide, and HCl.
Okay. Okay.
Mhm.
I got you. Okay. Well, that's all then. Thank you.
Yeah, no problem. All right. Anyone else have any questions about anything before we sign off?
Can you go back up to part B, the reaction matrix?
Right here? Yeah, sure. Good
Um,
question.
so we didn't use this or we did?
We didn't do this, but what this is asking you in the reaction matrix is basically any let me show you. It's easier for me to show you. I'm gonna take a picture of that part and then put it on my iPad. Give me 1 second to
When does this need to be submitted by?
but you got till next week to finish it.
Okay, thank you.
Mhm. Okay, let me make sure. Okay, here we go. Let me crop it out.
This assignment can be downloaded on Blackboard, right?
Yes, the whole document,
All right.
the introduction to the experiment and everything is all on Blackboard. Give me a second to crop this right quick and make it legible. Let's see. All right, it's coming up. All right, so your reagents were let me change this. Yeah, so your reagents were silver nitrate, if I'm remembering this correctly. So silver nitrate, sodium hydroxide. Is that right? And then what's the third one? Was it silver nitrate, sodium hydroxide? Was the third one water?
HCl.
Was HCl? Okay, HCl. All right. So and for reagent A, right? That first reaction in part B. Shucks, I cut it off. Hold up 1 second. Let me see if I can move this over. Yeah, in part B, you have to first figure out like which one of the unknowns, not unknowns, which reagent. So A, B, or C. You know when they went through and they just said reagent A, reagent B, or reagent C. You have to figure out which reagent was used in each one of those test tubes first. So you can do that by using some deductive reasoning up here, right? So where'd you see a precipitate? Where'd you see a cloudy mixture? Where'd you see gas evolution? And so all for the reaction matrix that's shown here, you would write in, let's say for instance, if we had HCl, and then calcium chloride. Right. So what you should get from that reaction, if there was a reaction that happened, right? If there was a reaction that happened, then you'll write the products. If not, I mean, you wouldn't. You just leave it, say no reaction. But if you did have a reaction, then you would have to write the products, right? And in this case, you're gonna end up with uh, the same thing on the product side, because I don't think a reaction happened there, right? But if we did something like sodium hydroxide and silver nitrate, because I know we added silver nitrate to one of those. So we did something like this. Right, then this is like a double displacement, right? So sodium is going to end up with the nitrate group, and then the hydroxyl is going to end up with silver. So on the other side of the arrow, you just swapping partners, right? So this would be sodium nitrate plus silver hydroxide. And the question is, if that was a precipitate or something like that that happened in that particular reaction, then you can use that reaction to deduce what reagent A, B, or C may have been when you added it to each one of your 5 known compounds. Does that make sense or no? So once you go through the reactions that are known and look at the observations that you made, then you can use those observations and go back and compare them to the observations you made in part B. And then you can figure out from that which pair of compounds were reacting together. You follow what I'm saying?
Yes, I see.
Okay.
All right. Well, thank you.
Yep, no problem. But that matrix is really, I think in the instructions in the experiment, you're only supposed to write into the matrix reactions that give you precipitates. But you can write them all out as for practice. As far as I'm concerned, that'll be great.
All right. Thanks.
All right. Any other questions? No? All right. All right. So if there are no other questions, I'm going to stop recording.